Friends, this is our second lecture of non-traditional machining process. Okay, we have seen that what is traditional process and limitation for using this traditional process, and also seen that why we are using non-traditional processes, and also we had already classified the non-traditional processes in four groups, that is depending on the energy used for that machining. First one is thermal energy. uh, that means if thermal energy is used, then the machining process is classified into that category. Then second one is mechanical, then electrochemical and chemical. Okay, so this is we are looking for now. Here are those what we have seen last lecture. This thermal energy, depending on thermal energy, mechanical energy, electrochemical energy and chemical energy. Now today we are starting with the first machining process, that is abrasive jet machining. Okay, first machining process, that is abrasive jet machining, or shortly called as AJM. Okay, let's see what is AJM is. Okay, it is mechanical method of material removal. Okay, this falls under mechanical machining process. Then the sharp edges abrasive are allowed to strike on a workpiece surface with high speed. It can effectively machine hard and brittle material like glass, silicon, tungsten and ceramic refractory material. It is specially used for brittle material. Keep one thing in mind, that brittle material. Okay, this is not used for softer material like rubber. Here is also given. This method is not suitable for softer material like rubber and plastic. Okay, so this abrasive jet machining is mechanical method of metal removal. The in this method, sharp abrasive of sharp edges strike on workpiece and remove the material from the workpiece surface. Then it is used only for removing the material from the brittle material like glass, silicon, tungsten, ceramic, refractory material, etc. This is not used for what? Softer material like rubber and plastic. What is principle of abrasive jet machining? Okay, in this process, principle of abrasive jet machining. In the process, mixture of gas or air and abrasive particle with high pressure is passed through the nozzle. The jet of mixture coming out through the nozzle is allowed to strike on the workpiece to be machined. Metal removal occurs due to erosion caused by abrasive particle impacting on the workpiece surface at high speed. Okay, you got the principle. What is principle of AGM? The mixture of, in this process, the mixture of gas or air, any gas or air is mixed with the abrasives, and it is allowed to fall on the workpiece surface with very high speed. Then by erosion action, the workpiece surface is machined. Okay, then let's see this figure. You can understand the principle of working from that. Here it is nozzle. You can see that here it is nozzle. Okay, nozzle from which a gas and air mixture is passed and allowed to fall on the workpiece with very high velocity. Then by erosion action, it is removing the material, as you can see over there. Then with repeated impact of abrasive, small bit of material get loosened and fresh surface is exposed to the jet. Velocity of the abrasive particle, for filling the blanks, it can also be asked in the exam. Velocity of the abrasive particle is 200 to 400 meter per second, and the distance between nozzle and the workpiece is 0.7 to 1 millimeter. This is also called as stand-off distance. Over here you can see that stand-off distance. Stand-off distance is what? 0.7 to 1 millimeter in abrasive jet machining. This parameter must be keep in mind. Okay, that is velocity is 200 to 400 meter per second, and the distance between nozzle and workpiece, which is also called as stand-off distance, which is equals to 0.7 to 1 millimeter. Okay, look at the figure now. You can see its different apparatus. Okay, gas or air supply. Okay, see over here, gas supply, filter is provided there. Then here is vibrator, and here is powder supply and mixture. Okay, this tank includes gas and abrasive material, and this vibrator keep vibrating that chamber to mix air and that abrasive powder. Then it is fed to the nozzle nozzle gun, and then from which it is impinged on the workpiece surface. Okay, now these are the component you can see over here. Okay, further the main component of the setup. Okay, let's see the main component of this abrasive jet machining. Nozzle, here you can see that nozzle. Second is abrasive powder, which is mixed over here. Then gas and air supply, gas or air is fed in this tank and mixing chamber. Here is mixing chamber. Okay, these are the main component of the abrasive jet machining. Let's see then what is nozzle, of which material it is made of. Okay, now as the abrasive particles are passing through the nozzle, there may be the damage of there may be damage of internal surface of nozzle. There may be, okay, of it due to wear. Okay, since as the gas is mixed with the abrasive and which are passing through that nozzle and fall or impinges on that material surface, as well as it rub against that nozzle material. Therefore nozzle will also erode. Okay, therefore to reduce wear, material of the nozzle must be hard. Okay, now the material like tungsten carbide, which lasts for around 12 to 30 hours, and sapphire, which lasts for 300 hours. Okay, these are two material. Tungsten carbide is last for around 12 to 330 hours, and sapphire is the material which lasts or which can stand for 300 hours. Okay, these are the harder material for passing that abrasives. Okay, cross section area of nozzle is around 0.05 to 0.2 millimeter square. The shape of orifice of nozzle may be round or rectangular. These are the things that you must keep in mind about nozzle. As nozzle is rubbing against that abrasives, it must be made of harder material. The material are tungsten carbide, which lasts for 12 to 30 hours, sapphire, which lasts for 300 hours. Then area of nozzle, orifice area, that means if this is nozzle and the jets are coming through this, then this area is called as orifice area. Okay, let me tell you again that where is orifice area. This is this diameter. Okay, this diameter is orifice diameter. Okay, which is 0.05 to 0.2 millimeter, 0.05 to 0.2 millimeter square. Its area is. The shape of orifice of nozzle may be round or rectangular. Then it may be round or rectangular. Distance between nozzle and workpiece should be minimum, that is around 0.5 to 5 millimeter, that is stand-off distance. Then abrasive powder. The material of the abrasive powder used is aluminum oxide, that's Al2O3, silicon carbide or sodium bicarbonate. These are the abrasive powders. The shape of grain should be sharp edged. Then grain size should be 50 microns. The mass flow rate is around 3 to 20 grams per minute. Okay, what is the description of abrasive powder is given over here. Powder is made of aluminum oxide, silicon carbide, sodium bicarbonate. The shape of grain should be sharp edge 10 to 50 microns and discharge rate is or mass flow rate is 3 to 20 grams. Then gas air supply. Okay, gas air supply. Now which gas is used actually in this machining process is the nitrogen or carbon dioxide gas is used, or simply air can also be used. Now mass flow rate is proportional to the gas pressure and quantity of abrasive used. Gas pressure is around 0.2 to 1 Newton per meter square. Then air density is 1.3 kg per meter cube, velocity with 150 to 300 meter per second and pressure of 2 to 8 bar. Okay, then mixing chamber. These are the different components, okay, in which nozzle, abrasive powder, gas air supply. Now we are looking for mixing chamber. It is chamber in which gas under pressure is mixed with abrasive powder in the required quantity. The required proportion of abrasive powder in the gas air is controlled by the amplitude of vibration of the mixing chamber. Okay, we have seen that vibrator over there. Okay, you can see the vibrator here. This vibrator vibrate the abrasives in this chamber. Depending on the amplitude, the quantity of abrasives is mixed with the air. Okay, if vibrator is vibrated more frequently or with larger amplitude, then more abrasive will be mixed with the gas. Then mixing chamber we have seen. Then let's see how the AJM actually works. Now look at this. Abrasive particle are stored in the hopper through which it is fed into the mixing chamber. Okay, abrasive particle are stored in the hopper through which it is fed into the mixing chamber. Then regulator between the hopper and mixing chamber control the feeding of abrasive particle to the mixing chamber. Gas air at high pressure is supplied to the mixing chamber through a pipeline. Now gas or air flow and its pressure is controlled by the pressure gauge and regulator. Okay, now then again next, mixing chamber carrying the abrasive particle vibrated by the vibrator, and this vibration controls the proportion of vibration particle in the mixture. This particle with air gas travel through the holes and enter into the nozzle with high pressure. The stream of mixture coming out of through the nozzle with very high speed called the abrasive jet impinges on the workpiece. The erosion caused by air impact enable the removal of material from the workpiece. Okay, this is the process of, or in this way the abrasive jet machining process is done. Okay, now process controlling parameter. That means to machine the workpiece in desired way, we have to control these three things: abrasive, gas supply and nozzle. Okay, now look at these parameters are adjustable and are used to control the process as per the requirement by the operator by keeping in mind the type of application and cost consideration. Okay, now abrasive. Type of abrasive used is, as we have already seen, Al2O3 and silicon carbide, SiC. The abrasive grain used is of spherical shape and having size of around 25 micrometer, then, or we can say micron, 25 micron. The mass flow rate is 3 to 20 gram per minute. These are, in this way the abrasive must be controlled. It should be of Al2O3 or SiC. Then this particle must be spherical, having sharp edges and 25 micron, and the mass flow rate must be 3 to 20 gram per minute. Then gas supply element. The type of gas used is nitrogen and carbon dioxide. Velocity of gas must be 150 to 300 meters per second and pressure is 2 to 8 bar. The gas flow rate is around 30 liter per minute. Okay, these are the gas supply arrangement, or this one is the parameter. Then nozzle. The material used for nozzle is either tungsten or carbide or sapphire. Okay, then here are three. Then the life of tungsten is 12 to 30. All these things we have seen already. 12 to 13 hours and sapphire is 300. The shape of the orifice nozzle may be a round or rectangular and having crossing 0.05 to 0.2 millimeter. The operating angle is, new thing one more, is 60 to 90 degree. The operating angle, that means the angle between workpiece surface and that nozzle must be 60 to 90 degree for better material removal. And the stand-off distance, which is 0.5 to 5 millimeter. Okay, this is the stand-off distance. That means stand-off distance is what? The distance between workpiece surface and nozzle outlet. Now, advantages of this AJM. What are the advantages of AJM? Is complicated activities and holes, cavities and holes of any shape can be easily machined. This is the first advantage. Complicated cavities and holes of small diameter can be machined. Brittle material of thin section can be machined. Low initial investment. No direct contact of workpiece and work tool or workpiece and tool. Low heat generated between the tool and workpiece. Easy to operate and maintenance required is this. These are the advantages of the abrasive jet machining. Now, what are its disadvantages? Low material removal rate. Okay, first most important is low material removal rate. Once the abrasive particles are used, they cannot be used of the damage of the sharp edges of the particle, because once they strike the workpiece, the edges of that abrasive get blunt. That's why this abrasive particle cannot be used again for this process. This process is not suitable for ductile material. We have already seen that this process is not used for ductile material. Poor machining accuracy cannot be achieved at high level. Then nozzle wear rate is high, as the abrasives get rubbed with that nozzle surface, inner surface, the nozzle wear is high. That's why we need harder nozzle. Then in this process there is possibility of abrasive particle getting embedded in the workpiece. Okay, and one more thing can happen. The abrasive particle may struck into the workpiece and causes less surface finish and will cause rough surface. Okay, that's why or these are the disadvantages of abrasive jet machining. Now its application, where the abrasive jet machining is used: machining brittle, heat sensitive material like glass and ceramic, then drilling hole, cutting slots, cleaning hard surface, polishing it, etc., and machining of semiconductor. In these places the abrasive jet machining is used. Now second one is water jet machining, that is also called as WJM. Now instead of gas, water is used. Same process is there. Now the high pressure water is allowed to pass through the nozzle. The stream of water which is coming out of the nozzle with very high velocity called the water jet. The high velocity water jet, having twice the speed of sound, when strike on the workpiece, removes the material easily. The type of jet used in these machining processes are pure water jet and abrasive water jet. This water jet machining process is same as like AJM, but in this process, just instead of gas, in one process. Okay, you can see over here abrasive water jet. Okay, in which water in the water abrasives are mixed, and the same process is done as AJM. And in this, pure water is used. There are two methods: pure water and abrasive water jet. Okay, now in pure water jet, only water is used for cutting soft material with low cutting forces. You can see which material is you cut with the help of this machining process: softer material, cutting soft material. Now further we will see this water jet process. Now here in abrasive jet, the abrasive particle with water is used. This jet is useful for putting hard material, stone, composite, ceramic. Okay, In this process, or in water jet machining process, the particle are mixed, abrasive particle mixed with water. This jet is used for cutting harder material, stone, composite and ceramic. Then now, principle of water jet machining, same principle as IJM, no difference. High velocity water jet is allowed to strike on the given workpiece. Then during this, kinetic energy of water is converted into pressure energy. This pressure energy induced stress gradually on the workpiece. When this induced stress is high enough, unwanted particles of the workpiece are automatically removed. Okay, these are the this is the principle of working of abrasive jet machining process. Now look at the figure and component of water jet machining. Okay, now reservoir. Okay, first is reservoir. Here is reservoir from which fluid is supplied. Hydraulic pump you can see over here. Then intensifier. Okay, here is intensifier. We will see what are the uses of that all the component. Accumulator, here is the accumulator. Then control valve, here is control valve. Then flow regulator, flow regulator, here is okay, flow regulator. Then nozzle, here is the nozzle. These are the different component of water jet machining process. Let's see what are actually this. Okay, first is water, that is to be in the machining process. Hydraulic pump, second one is hydraulic pump. Hydraulic pump, it lifts the water from the reservoir and supply to the intensifier. What is intensifier? It takes the water from the hydraulic pump and pressurize that water to a desired level. Accumulator, it is used for temporary storage of pressurized excess water supply from the hydraulic pump through intensifier. When there is shortage of supply of pressurized water to machining area, the stored water in the accumulator is used to maintain the constant pressure in the system. So this is used to maintain the constant pressure in the system and eliminate the pressure function. Control valve, it is used to control the direction and pressure of pressurized water, which is used to be supplied through the nozzle. Flow regulator, it is used to regulate the mass flow rate of water in the system. Nozzle, it converts the pressure range of pressurized water into kinetic energy, which is having very high velocity around 900 meter per second. It has an orifice whose diameter is 0.08 millimeter to 0.5 millimeter. The material of nozzle used is synthetic sapphire, which is wear resistant and easily machinable. These are the different component of the water jet machining process. Now working of WJM. Now water from the reservoir pump in the intensifier using hydraulic pump. The intensifier increase the pressure of water up to 200 to 400 megapascal. Excess supply of pressurized water is sent to the accumulator for storage. That pressure falls, the accumulator will supply the water, or which will maintain the required pressure. Required quantity of pressurized water then enter the nozzle through control valve and flow regulator. Control valve control the direction of water. Flow regulator regulate and control the flow rate of the water. Now the nozzle converts the pressure energy of water to kinetic energy, which is having a very high velocity. When high velocity water just strike the workpiece, stresses are induced on workpiece surface. These include the stress used to remove the material from the workpiece. Okay, in this way the working of WJM is done. Then process controlling parameter in WJM. As in AJM, same things are to be controlled over here, that is stand up distance, wear rate of nozzle, fluid pressure and jet fluid. Okay, then first is stand up distance. It is the gap between nozzle and workpiece. Material removal increase with increase this of stand up distance up to certain limit and then falls gradually. Then wear rate of nozzle. It depends on hardness of nozzle material, pressure and velocity of jet and nozzle design. Fluid pressure. Fluid pressure is increased with the depth of cut. Then jet fluid. It must have low viscosity to minimize energy losses and must be non-corrosive, non-toxic, common and inexpensive. Now, advantage of WG. It is faster process. It prevents the formation of heat effects zone on the workpiece. Automatically clean the surface of workpiece. It has excellent precision. Tolerance up to 0.005 millimeter can be obtained. Does not produce hazardous gas. This process is eco-friendly. Then burr produced on the workpiece is minimum. Disadvantages of AJM. Only soft material can be machined. Very high thick material cannot be machined. Initial investment is high. This process is not suitable for mass production. High maintenance is required. Application of to cut thin non-metallic sheets, to cut rubber, wood, ceramics and many other soft material used in food industry, used for machining circuit boards. Okay, these were the advantages, disadvantages of WJM. Now further we will in further lecture we will see EDM, that is electric discharge machining. Today we will stop here. Thank you.